Hello and welcome to today's presentation. My name is Mark Berthelin, and today I will be talking about the RSA crypto system. The RSA crypto system was created in 1977 by Ronald Rivest, Eddie Shamir, and Leonard Edelman, hence the name RSA. Its purpose? Well, it is used to encrypt a message in order to safely communicate with somebody using an encrypted key, a public key, which is what made it so unique when they created it using a public key. It was one of the first, if not the first, system that used a public key. But how does it work? Well, first you're going to have to create your public key, which will be made up of two numbers. Then you will use that public key to encrypt your message. And then finally, you will use the private key, which can be found when creating the public key, in order to decrypt the secret message. Now, there are some numbers that you're going to have to use, so there are going to be some maths behind it. Let's do that together. First, you're going to have to choose two unequal prime numbers, which we will name Q and R. Then, using Q and R, you will be able to figure out the first part of your cryptid key, which will be N. N will be equal to Q times R. Then you will calculate P, which will be equal to Q minus 1 times R minus 1. Now, here's an example. Let's say we picked Q to be equal to 3 and R to be equal to 11. Then N will be equal to 3 times 11, that's 33. And P will be equal to 3 minus 1 times 11 minus 1, which is 20. Then we're going to have to choose another number, E. E has to be coprime with P. That is to say, it must have only one common divisor with P, which is 1. Then you're going to have to use D. D will have to be inversely modulo to E, which means that when multiplied by E will be equal to 1 modulo P. So if we picked E to be equal to 7, because 7 and 20 only have one common divisor, which is 1, then D will be equal to 3. So now we have the two members of our public key, our cryptid key, N and E. So let's say we picked a message, which is 14. Then our message we will then turn into our secret message. So we'll name it S. S will have to be equal to M to the power of E modulo N. That is to say, S will have to be equal to 14 to the power of 7 modulo 33. Now, if you use a calculator, you will find that that will be equal to 105,413,501 modulo 33, which on the top of my head should be equal to 20. All right, so our secret message is equal to 20. So if somebody were to intercept the message, they would get 20 instead of 14, thus not getting the proper data. Now, we will use S to determine what is the value of M, which will be, in this case, the job of the person receiving the secret message. Now, M will be equal to S to the power of D modulo N. Just like earlier, we simply replace in the formula the E by the D, because the two members of our private key are D and N. So M will be equal to 20 to the power of 3 modulo 33. If you type that into your calculator, you will find it will be equal to 8,000. Modulo 33, that would be equal to, well, 14. Hey, that's our message. All right, so that is how we decrypt a message using the decryption key, the private key. So let's summarize what we've seen today. We discovered what the RSA crypto system was, how it worked, how it was completely groundbreaking when it was created, because it was the very first system to have ever used a public key. We have learned how to encrypt, how to decipher, to decrypt the message, and through that process, we have learned how incredibly complicated it can be to decipher the message without possessing the private key, which can only be found if you were the one to actually create the public key in the first place. So this is how safe this system is, because it ensures the communication of data, of information between two individuals. I would like to thank you for listening, for your attention, and for your time.